Murray, Public Relations and Marketing Communication Manager at Biosoil Enhancers. Welcome to the adventure of Biosoil Enhancers and the technology of Sumagrow. Every day we are committed to providing the highest quality products that are soil friendly, people friendly, and future friendly. We're often asked what the technology of Sumagrow is and how our products are made. So we'd like to take you on a tour of our facilities. You'll meet the team, visit our labs, and learn about how our products are made. First, let's meet the team. Now that you've met the team, we're going to show you the process of how products containing Sumagrow are made. We're going to take you from the lab, to the greenhouse, to the field, to the customer. Let's get started.
We're really excited to learn that there is a company in Hattiesburg that manufactures bioenhancers and microbial-based preparations to enhance plant health.
The process begins in a laboratory, where microbes have been isolated, screened, and functionally characterized. The bacteria and fungi have been identified down to the molecular level. From these microbes, Biosoil Enhancers produces polymicrobial products that are synergistic, complementary, and multifunctional, composing the award-winning formulations of Sumagrow. Mass production begins with pure cultures that are stored cryogenically at -70 degrees Celsius. These pure cultures are subcultured on Petri plates, where the process of incubation and growth begins. The pure subcultures are grown on solid media and then go through an initial quality control check to verify purity. From the solid media, the microorganisms are then grown in larger liquid volumes for mass production. As the microorganisms are grown from the pure cultures, they are scaled up sequentially in volume. The microbial biomass is then separated from the liquid media through a process of centrifugation. All processes are completed in a sterile environment, maintaining quality, uniformity, and purity, which is checked by a quality control manager.
Once the microbes are sourced, we turn them over to production, where they are grown, blended, bottled, and shipped. Let's see how it works.
So the last phase in our industrial scale-up of our microbial growth involves these bioreactors, in which we take a small inoculant of each bacteria, place them in a large fermenter, and allow them to grow up to volume. This allows us to keep up with supply and demand in large quantities.
From the bioreactors, the microbes are taken to the mixing process, where they are blended with a humic carrier. Using a state-of-the-art automation system keeps the process continuous, eliminating the need for constant calibration, and allows for quality control checks throughout the production of the product. At this point, the product is ready for distribution. Each specific formula is packaged, labeled, and prepared for shipping and handling.
In addition, through vigorous research and development, we continually work to make new products to meet the needs of our customers. Research and development remains fundamental to ensuring that we stay in front of the developing needs of our customers and ready to assist them in meeting the demands of growing regulations.
Testing of a new product's efficacy begins in the laboratory, then moves to the greenhouse. Once a formulation passes the greenhouse test, it's on to the field.
Here we are today in a field in Mississippi where we're looking at the efficacy of our product on tomato plants. We've worked also with corn and soybeans locally. This year we're getting ready for fall crops where we're looking at kale as well as collards and a few other common fall crop vegetables. We also do nationwide as well as in different countries, so we've moved globally. I just got back from a trip from Guatemala where we looked at sugarcane and banana plantations and the use of our product with their soil type. When it turns over, you're incorporating the microbes into the soil, so then the roots can come out and
incorporar los microorganismos y que ayudar a que aflojar que la raíz crezca mejor.
So really it's not about just using it in one different soil type, it's the myriad of different soil types and the benefits that you see from our product really across the board. What I do is really set up the experiments and help with some of the implementation of it. So we look at control groups and treatment groups with different fertilizer regimes with and without our product to look at how our product reacts across different soil types and across the board with different crops. So that's really one way that our product's able to benefit a number of ecosystems around the world, is that it's not just about the crop you're growing or the land that you're growing it on, it's about enabling the soil to become healthier for the long-term viability of the land and of the crop.
BioSoil Enhancers has partnered with the University of Southern Mississippi to make Sumagrow even better. Their collaborative research focuses on two aspects: testing different formulations of Sumagrow with different plant types, and to improve the overall shelf life of the product.
We're looking at how individual strains within Sumagrow preparation survive over time under different environmental conditions. So we tagged a couple of strains from Sumagrow with antibiotic resistance, and then we put them into humic acid. And so these individual samples of humic acid were stored over time at different conditions: room temperature, under refrigeration, outside at ambient temperature, and at higher elevated temperature. And so what we do then is we use a special assay that we designed, which uses this 96 well microplates, where we can recover individual strains and quantify their population and see how these strains survive over time under different conditions.
You know, in the end, this is really not about the equipment. It's not about the bioreactors. It's not about all the microscopes and lab equipment. It's about leaving a legacy for future generations. It's about making a meaningful difference, okay, for those yet born. And so the soil, this soil, is our most precious asset. It sets the table for our food. It grows this grass, okay, and takes care of the plants and trees to produce oxygen we need to breathe. It's our survival. And unless we take care of it, we can have significant problems. In the year 2050, we're going to need as much farm-grown produce as we've grown since the Industrial Revolution. Where does it come from? Where does the nutrient base come from? This is our adventure, our journey, and we'd like for you to join us.